The global semiconductor industry is witnessing a fierce rivalry. Two major players are at the forefront: China's Semiconductor Manufacturing International Corporation, or SMIC, and Taiwan Semiconductor Manufacturing Company, known as TSMC. Both companies are crucial to the global tech supply chain. They produce the chips that power our smartphones, computers, and countless other electronic devices. TSMC currently holds the technological edge. The company has been producing cutting-edge 3-nanometer chips since 2022. These advanced chips offer superior performance and energy efficiency. SMIC, on the other hand, is playing catch-up. The Chinese company is still working to master older technologies. This technological gap has significant implications for the industry. It affects everything from pricing to market share. The competition between SMIC and TSMC is not just about business, it's also a strategic battle with global economic and technological dominance at stake. Gap 3S. Before we dive deeper into the fascinating world of semiconductor manufacturing, we have a quick request for you. If you're enjoying this video and want to stay updated with the latest insights and developments in the tech industry, don't forget to hit the subscribe button. Your subscription helps us bring you more high-quality content and keeps you informed about the cutting-edge advancements in technology. So go ahead, click that subscribe button and join our community of tech enthusiasts. Thank you for your support, Gap 3S. TSMC's technological prowess is undeniable. The Taiwanese company has consistently pushed the boundaries of semiconductor manufacturing. Their 3-nanometer chips are a testament to their engineering capabilities. These chips pack billions of transistors onto a tiny piece of silicon. This allows for faster processing speeds and lower power consumption. SMIC, however, faces significant hurdles in catching up. The Chinese company relies on older, deep ultraviolet, or DUV, lithography technology. This technology is not as precise as the extreme ultraviolet, or EUV, lithography used by TSMC. EUV technology is essential for producing the most advanced chips. Intel's CEO, Pat Gelsinger, has publicly stated that China is about a decade behind in semiconductor manufacturing. This technological gap is a major challenge for SMIC. The company is investing heavily in research and development to close the gap. However, it remains to be seen if they can catch up to TSMC. Despite the technological gap, SMIC is not backing down from the competition. The company is employing an aggressive pricing strategy to gain market share. SMIC is targeting the market for mature nodes, which are older chip designs. These chips are still in high demand for a wide range of applications. SMIC is offering significant discounts on its mature node chips, sometimes up to 40%. This pricing pressure is putting a strain on Taiwanese rivals like United Microelectronics Corporation, or UMC, and Vanguard International Semiconductor Corporation, or VIS. These companies are being forced to lower their prices to compete with SMIC. This price war is reshaping the semiconductor landscape. It is leading to a shift in orders from Taiwan to China. This is part of a broader trend of China seeking to become more self-sufficient in semiconductor manufacturing. The Chinese government is providing significant financial support to SMIC and other domestic chip makers. SMIC's aggressive pricing strategy has had a mixed impact on its financial performance. The company reported a 27% year-on-year revenue growth in 2024, reaching a record $8 billion. This growth was driven by strong demand for mature node chips. However, SMIC's profits took a hit. The company's net profit plunged by 45.4% to $493 million in 2024. This decline in profitability can be attributed to several factors. The price war with Taiwanese rivals is eroding profit margins. Additionally, SMIC is facing higher operating costs due to its expansion plans. Despite the drop in profits, SMIC remains committed to its growth strategy. The company is investing heavily in new fabrication plants, or fabs, to increase its production capacity. SMIC is betting that its low-cost manufacturing capabilities will allow it to gain market share in the long run. Section 5. Capacity glut, too many chips. SMIC's expansion plans are part of a broader trend in the semiconductor industry. Chinese foundries are significantly increasing their production capacity, particularly for mature nodes. This is leading to concerns about a potential oversupply in the market. The semiconductor industry is cyclical. Periods of high demand are often followed by periods of oversupply. The current expansion in China's chip-making capacity comes at a time when global demand for electronics is slowing. This could lead to a glut of chips, which would put downward pressure on prices. An oversupply of chips would benefit buyers in the short term. However, it could have negative consequences in the long run. If chip makers are unable to make a profit, they may be forced to cut back on investments in research and development. This could stifle innovation in the industry. Section 6. China's semiconductor ambitions, a long road ahead. China's push for semiconductor self-sufficiency is driven by several factors. The Chinese government sees the semiconductor industry as a strategic imperative. They want to reduce their reliance on foreign companies for these essential components. China is investing billions of dollars in its domestic semiconductor industry. The government has launched several initiatives to support the growth of local chip makers. These initiatives include subsidies, tax breaks, and other forms of financial assistance. However, achieving self-sufficiency in semiconductors is a daunting task. China still lags behind Taiwan, South Korea, and the United States in terms of technological sophistication. Building a world-class semiconductor industry takes time, money, and expertise. Section 7. The US factor export controls and innovation. The United States has emerged as a major obstacle to China's semiconductor ambitions. The US government has imposed export controls on American companies, restricting their ability to sell advanced chip-making equipment to China. These export controls are designed to slow down China's technological progress in the semiconductor industry. The US is particularly concerned about China's military modernization efforts. They fear that China could use advanced chips to develop more sophisticated weapons systems. Despite these restrictions, Chinese companies are finding ways to innovate. They are investing heavily in research and development, exploring alternative chip designs and manufacturing processes. Whether these efforts will be enough to overcome the US export controls remains to be seen. Section 8. Market tremors. Navigating the semiconductor landscape. The semiconductor industry is in a state of flux. The competition between SMIC and TSMC is just one part of a larger story. The global chip shortage of recent years has highlighted the importance of semiconductors to the global economy. Governments around the world are now taking steps to secure their semiconductor supply chains. The United States, the European Union, and Japan are all investing in domestic chip production. This is leading to a more fragmented and competitive semiconductor landscape. Navigating this complex environment will require companies to be agile and adaptable. Those that can adapt to the changing market dynamics will be best positioned to succeed in the long run. Section 9. The future of the chip competition and collaboration. The rivalry between SMIC and TSMC is likely to continue for the foreseeable future. Both companies are determined to become leading players in the global semiconductor industry. This competition will drive innovation and push the boundaries of what is possible in chip making. However, there is also room for collaboration in the semiconductor industry. Addressing global challenges like climate change and pandemics will require cooperation between companies and countries. The development of new technologies like artificial intelligence and quantum computing will also depend on collaboration. The future of the chip is bright. Semiconductors will continue to play a pivotal role in shaping the 21st century. The companies and countries that can master this technology will be the ones that shape the future.